last property that we have for probabilities that we're going to work through here is what's called the product rule. So if we have two events and we're going to call them A and B and they're in the same sample space, then if we want to find our probability of A and B happening, that intersection of these two events, one way we can do this is to take our probability of A and multiply this by the conditional probability of B given that A has already happened. So we're finding our probability of A, and then we can multiply it by this conditional probability to find our probability that both of these two events have happened. This also works for more than two events, and this is what we call our probability of successive events, where essentially we can continue this chain of multiplying by conditional probabilities that the previous events have already happened. An example with this is if I had three events, A, B, and C, and I want to find the probability of A and B and C happening. All three of these events need to happen. Well, we can do this by taking our probability of A, multiplying this by our probability of B, given that A has already happened, and then multiplying by this third conditional probability of C, given that both A and B have already happened. And essentially, you could just continue this chain if you had four events and you had an and D in your original probability. Then you would multiply again probability of B, given that A and B and C have already happened. Okay, so now let's work through two examples with this. We have a deck of cards, and we're drawing two cards from our deck. The order of the selection matters, and the first card drawn is not replaced into the deck. And we first want to find the probability of selecting two aces from our deck of cards. So this means we are essentially trying to figure out our probability of getting an ace and then getting another ace. So let's think about our deck of cards. In our deck, we have four different suits, and each suit contains one of each of the values of it. So this means that there are four aces in our deck of cards. And our deck of cards, each of the four suits have 13 cards. So 13 times 4 gives us 52 cards in total in the deck. So now that is our probability of the first card being an ace. So now we need to multiply this by our probability of the second card getting an ace, assuming that that first one we actually got an ace. So we are under the assumption that we pulled an ace for that first card, and now that ace is no longer in the deck. It is sitting out to the side because it is not replaced. So now we no longer have four aces in our deck, but we have three left to choose from. So we have three aces out of our number of cards in the deck, which is no longer 52 because we have that ace sitting out on the side, not in the deck. So we have one less card, so it's out of 51. And now we can multiply these two fractions together. When we multiply fractions, we multiply the numerators together and multiply the denominators together. So this is going to give us 12 out of 2,652. So it's a very small probability that you would get two aces in a row. Our next one, we want to find the probability of getting an ace of diamonds and then a black card. So to start, how many ace of diamonds are there in our deck of cards? Well, this is stating a specific card in the deck, and there's only one of them. So there's only one ace of diamonds out of the 52 cards in the deck. So now we are going to assume that we actually pulled that ace of diamonds from our deck of cards, and that is sitting out to the side. So now let's figure out our probability of getting a black card. Well, one thing to note is that ace of diamonds is a red card. The diamonds and hearts are reds, while the other two suits are black. So we still have half of the deck being black, the other two suits. So there are 26 cards in the deck still that have a possibility of being a black card to be pulled. But once again, we don't have 52 cards in our deck because that ace of diamonds is sitting out to the side. So we have one less card in our deck to give us 51. So now we can multiply these fractions together to give us 26 out of 2,652. So that would be our probability. You could simplify these fractions a little bit, but I usually don't require that in my classes to simplify fractions. But you could do that with your scientific calculator to reduce the fractions.